Welcome to Train Signal. You are watching Storage, Connectivity, and Multipathing. So we're going to jump into a couple of things here, a couple of advanced features. First off, we're going to talk a little bit about fiber channel real fast. So this is not an in-depth fiber channel discussion. It's just a little bit of an information, mainly because we need to discuss one feature that is covered in the blueprint, which is NPIV. So real quick, primer on fiber channel addressing, I guess. Fiber channel has a concept of initiators and targets. Servers are usually known as initiators, so like your vSphere hosts, and your storage arrays are usually known as your targets. So if you have an EMC array or a NetApp or something like that, that's normally your target. And the way that they talk is you have to go through a process known as zoning, and this gets done usually on your fiber channel switches. So within your fiber channel fabric, you zone things. And what you do is you zone one or more initiators to one or more targets. Normally it's single initiator, single target, meaning 1-to-1. So you would zone the HBA port in your server to one or more front-end ports on your storage array. You'd zone the other port on your server to the other front-end ports on the storage array. Normally one's on A fabric, one's on B fabric. So usually you have two storage fabrics for redundancy. And the idea is this is a security process. So by default, nothing is allowed to talk to each other in a fiber channel network. So to allow a host to see the storage array, you have to do this zoning. So you create what we call these zones or zone sets. Addressing on a fiber channel fabric is similar to MAC addresses with Ethernet. So a device or a HBA, host bus adapter, which is what you use to connect into a fiber channel environment, has a couple of address types. One is called WWNN, Worldwide Node Name. So this is like if you had a dual port HBA, it would have a single WWNN, a single worldwide node name. It would have two worldwide port names, WWPNs, and these are an address for a specific port. So like I just said, a dual port HBA would have a single WWNN and two WWPNs. These are hard-coded to the HBA, very much like a MAC address. So the idea is that you don't get duplicates or have any, mistakes like that. So normally they are burned in, but we do have a process where we can do these via software. And as I said, by default, devices on the fiber channel fabric are not allowed to communicate. Zoning is the process of allowing that communication. So basically, a zone contains usually the WWNN, the WWPN, the port number of that HBA port, and the WWPN of one or more ports on the storage array. So you put those together, it's called a zone, and then they're allowed to communicate. You zone initiators to the targets using the WWNNs and WWPNs. The exact process depends on the make and model of your switches. So with Cisco MDS, which is what I use a lot, you can use the command line interface or Fabric Manager GUI or the new Data Center Network Manager GUI, whichever you want to use. Details are kind of outside the scope of this, but I want you to understand the process because we're going to create some of these WWNNs and PNs here in a minute, and you need to understand kind of just at least the overall functionality. For the VCAP exam, they're not going to give you access to fiber channel switches for zoning or anything like that. So I don't think you need to understand it at that level, and most vSphere administrators don't. Well, in larger environments they don't because they usually have a team that manages storage. Smaller environments you may, but you may be an NFS shop or iSCSI and not deal with this at all. But I think it's important to understand at least the concepts. So let's talk about NPIV. NPIV stands for In-Port ID Virtualization, which is a big word, or group of words, I guess you'd say. What it does is it allows a single what we call an in-port to have many initiators behind it. So if I have a fiber channel switch, Cisco MDS, 9148, I have a port set up to plug a vSphere host into it. That's called an in-port. One way to remember it is that sounds similar to end port, as in an end device or an end station. Normally, each end port has a single initiator behind it, a single WWPN, because you have one port out of your server plugged into one port on the switch. But NPIV lets a single in port have a bunch of initiators behind it. And why would we want to do that? Well, let's find out. This requires a switch operating in what we call NPIV modes. It's just a mode you have to do on your switch. Some switches like Cisco, when you enable that mode and enable this functionality, it requires a reboot of the switch. But just do remember that that is a requirement. Virtual machines are configured to use NPIV. So each VM gets its own WWPN for use, and it's manually zoned each one through the fabric. So the idea of this, the reason we would enable this on the switch is instead of using just the the addresses on the server HBA, we would actually assign addresses to each of our VMs and be able to zone them individually. Why? That's a great question. There's really not a lot of use cases for this. It's considered to be a solution looking for a problem. And when I was starting this slide deck for this course, I even threw out to the Twitterverse. I said, "Hey, has anybody got a great use case for NPIV yet?" And the answer was a resounding no. The only thing really is like maybe some QoS for specific VM storage traffic. So knowing exactly which VM it's for, you could do some things in the fabric. Security functions, that might require direct zoning, where you want to do something different for that VM but not the host. But I'll be honest, I've never deployed this in production. It's a little annoying that it's even on the blueprint for such a limited use case. But lucky for you and me, and I guess us, is that it's not hard to configure, assuming your switch is set correctly. Keep in mind, this is good, one thing I forgot to mention, you have to use RDMs. You're not going to zone a VM direct to a VMFS data store. That's not going to work because the Windows VM doesn't understand VMFS. You're going to zone it through a LUN off of the fiber channel storage array, and the host is going to have access to it, just like it would an RDM. So it'll just see a raw mounted volume, it formats it, and does whatever it wants to do. So let's go to the lab. In the lab, we're just going to do something real simple. Enable NPIV support on a VM. This will take all of about 3 seconds. So with that, let's go ahead and jump on over to the lab. Here is vCenter. I'm going to pick a random host because I do not have a fiber channel storage array sitting in my lab. Doesn't matter because we can still enable it. So I'm going to pick, I don't know, my Netformix VM. And I'll edit this VM settings. So the way you enable it is you go to Options, you go to Fiber Channel NPIV, and the host has to be shut down. I forgot that, so let's pick this guy. So if it's grayed out, it means your host isn't, or your VM's not shut down. So again, Fiber Channel NPIV. By default, it's set to temporarily disable. To me, that's odd wording because it's something you almost never enable, but whatever. Clear that, and then you can create new WWNs. So you say generate, and you say how many node names and how many port names you want. Now, normally, you would have at least 2 port names, but you got to remember there's no actual HBAs in these VMs. You'll just need to keep in mind you'll need to zone this across both fabrics when you create these. So it's a little odd. You'll have one that you're going to zone everywhere, but it is. So we say OK. Let's edit it again. Back to Options, back to Fiber Channel, and there are your addresses. So that's what you would zone right there. And if you want to change them, you can generate new ones. Warn you about that. You can remove them. It'll warn you about that. Or whatever, but that's how you'd come in and change them. So again, not too difficult, but real simple. So if you get that on the VCAP and they say, hey, you got a VM, you need to do some special stuff, we've already configured the switches, go generate some WWPN and WWNNs, that's all you got to do. So that's it for the simple lab. Back to the slides. Now let's talk a little bit about storage filters. These are pretty simple. So within vCenter, you can use storage filters to exclude certain types of storage from appearing. That way you don't accidentally format a VMFS data store LUN or something like that. And the way you do these is you add or change the keys that I'm about to show you in vCenter. So you go to a vCenter administration on the menu bar, vCenter server settings, and advanced settings. So actually, let me just show you. So vCenter, administration, server settings, advanced. So you're going to go in here and you're probably going to have to type these in. I don't think they're, let's see, I don't see them. Yeah, they're not in there by default, so you'll need to type these in. So here they are. There's 4 of them. There's only one that I would ever actually use, but let's talk about that. So the first one is VMFS filter. You can see the key on the right, config VPXD filter VMFS filter. These are on by default. They are filtering and activating by default. So to turn this off, you would add the key and do it as false. So if you set this to false, when it's on by default, it filters LUNs already used as VMFS data stores on a managed host. So vCenter knows of the hosts he sees, and he knows which data stores and LUNs they see. So by default, if you go to a vSphere host, go to the configuration tab, storage, add, and say add a LUN, it filters out the ones already in use by VMFS. If you type the key in and say false, it'll show you all of them. Why would you want to do that? I don't know. Actually, I think it was Duncan Epping at VMware had an article on these, and he said the same thing. They're neat, but I would never turn this off because you're going to end up formatting an existing VMFS data store. So keep that in mind. Next is RDM. It's basically the same thing, but RDMs. Filters LUNs already used as an RDM on a managed host. So again, if you put this in and false it, it will then show the LUNs that are already in use, and you're going to make a mistake. The next one is called Same Host and Transports Filter, which is a funny name, but I'll explain it to you. It filters LUNs that cannot be used as VMFS data stores because of incompatibility. What does incompatibility mean? Well, the common one here is, let's say you've got a cluster of 8 vSphere hosts. 6 of them are zoned to see a LUN, the other 2 are not, and you want to add that LUN as an extent to an existing data store. It won't show that LUN to you because only 6 of your hosts have access, not all 8. Therefore, it's not compatible with the cluster. So if you turn this off, it will show it, but then those 2 unlucky vSphere hosts aren't going to have access to that LUN, and I don't honestly know what's going to happen to that data store when you try to use it. So again, I'd never turn this off. The last one is the only one I may turn off. So it's called the host rescan filter. If you ever notice, when you add a new data store to vSphere, it automatically tells all the hosts to rescan their LUNs and their data stores, and everybody picks it up. If you turn this off, it says don't do that. And so if you're going in there and creating a bunch of data stores or doing some maintenance, you may not want to keep kicking off rescan jobs every time you make a change. So you may want to temporarily add this, set it to false, and turn that feature off. So this is actually usable. Of all these in the VCAP, my guess is that's probably the one that they'd have you do. I don't expect you to remember or memorize these keys. They are in the, I believe it's in the storage guide and the documentation. I would know where they're at in the documentation set and look them up if you need them, but they're just called storage filters. So now a little bit about VM Direct Path. So VM Direct Path is actually hit both in storage and the networking sections of the blueprint. So just a heads up, we'll touch on it in the networking side, but won't do the demo again. VM Direct Path is pretty simple. It allows a VM to directly use a NIC or an HBA, meaning it bypasses the hypervisor. This used to be called hypervisor bypass. But there's a couple of downsides. One of them is you can't let vSphere use it or another VM use it. It literally gives it access to that PCI device in the server. You get a little higher throughput and lower CPU use, but it's questionable, right? I used to see people want to do this more and more because they got to have this fantastic network throughput, or they got to give an HBA direct up to a server or something like that. But the only time I see VM Direct Path used these days is people building home labs and want to pass through internal RAID controllers up to a VM and build a virtualized FreeNAS box or something like that. Things like that. It's rare that we see this in a production environment. It's very, very edge case for sure. Drawbacks. You can't vMotion a VM that's using it because that PCI device doesn't live in that other server. Even if your servers are exactly the same add-on card, same slot, same port, same everything, it's a different device, and therefore you can't do it. HA. Can't do HA. Can't reboot that VM on another host because that device doesn't live there. So no HA. No DRS because you can't vMotion. No suspend and resume because of some functionality in how it has to do the memory access. You can't suspend or resume the VM. No snapshots either. Beginning to see why nobody uses this. And no hot add. So can't do that either. Basically, it really anchors down that VM to a host and gets rid of a lot of really great features. And it can be very picky. So if you go read some of the support forums and things like that online for vSphere, a lot of questions are, hey, I'm trying to pass through a graphics card to a VM, doesn't work well. I'm trying to pass through a random RAID controller, doesn't work well. I mean, this thing is really built for NICs and HBAs and not much else. So don't try to get too fancy and expect it to work. I mean, in a lab, you can do whatever, but in production, be very cautious on how this is. So let's do a bit of lab work. So we're going to enable VM direct path on a host, pass through a device to a VM, and show the device in the VM. So with that, let's go ahead and jump over. Back to vCenter. So let's show you how to enable it first. I've already enabled it on Megatron to save us a few minutes, but I'll show you the general steps here. Host, configuration, advanced settings under hardware. So hardware advanced settings. And this is really the only advanced setting. But the way it works is this. You get to pick which device it is. I've already done it, but the way you do it is you click Edit, and it's going to give you a list of all the PCI devices that it sees. And if you notice things like my Intel NICs here that I'm actually using for vSwitches, it actually puts the names out here, which I think is kind of handy. The ones without the VM NICs beside them are currently unused in the server. So you can see those. You can see my internal SATA controllers, my USB chipsets, things like that, my built-in Matrox GPU. But you basically pick the device, like I'll pick this one, and it's going to tell you the device has a dependent device. The dependent device will also be marked. What that means is a lot of times you see like right here, a PCI Express root port or like a bridge or something like that. It'll automatically select that. One thing to also keep in mind is sometimes you will see, say, PCI quad port NICs, and the way that they're built and the way that their chipsets are, you can't pick one port and pass it through. The whole card has to go through. So it really depends on how you do this stuff as to how well it works. So, that's kind of a gotcha here. I'm trying to think. Yeah, see, like mine right here, it's got 2 ports on a single card, and it's probably going to yell at me. Yeah. See, it's going to tell me that there's a dependency warning, and it'll automatically mark as pass-through as well. So it's going to want to do both of those ports instead of just one. So that's something to keep in mind, so look at this. So we'll hit cancel. Normally you'd hit OK, and it'd say, OK, I can do this, and then right here it's going to say, as soon as you reboot the host. So you have to put the host in maintenance mode, evacuate to VMs, and reboot the host, which is what I've already done. And when it comes back up, hopefully it'll list this here, and you'll see it. So let's see which VMs are on this guy, and I'm just going to randomly pick one. XP2. Let's edit. Actually, you have to shut the VM down. I'll show you that now. So what you do is you add hardware like you normally would, and you're going to do PCIe device, and it's going to tell you can't do it while the device is up. So, are there any on Megatron already shut down that are easy to use? Not that. Nah, I'll just shut him down. And we'll shut down the guest. So down he goes. Now, while I'm talking about this and waiting, the other gotcha. That device is going to be handed to that VM. That VM is going to have control. That VM needs to have a driver for that device. And we're going to have to find out why this doesn't work, because I'm about to pass this NIC to an XP machine. XP doesn't have a driver. Now, I could go download one if I really cared, but normally if you want your device to work in the VM, you need to have a driver for it. So if you're trying to pass through a PCI device that doesn't have a Linux driver to a Red Hat machine, it's not going to do magic. It's not going to make it work. It's not going to use a vSphere driver. It's not going to do anything like that. It's just going to go, I see a device, but I don't know what to do with it. So keep that in mind as well. So we'll add PCI device, say next. It says here's a list of all devices that you've passed through, only the one. So we'll say next. It says, hey, that looks fantastic. And you're finished. Save that. Open console. Power this guy up. So again, it's going to boot up. Oh, that device is already in use. I must already have a device with it in use. Who is using it? Who is it? Not you. I know it's one of these guys because I used them to test this the other day. It's this guy. So let's just jump over to him since he already passed it through. Process is the same. Just saves us the trouble of booting the machine. Genuine advantage, blah, blah, blah. So it's already tried to install a driver, so let me show that to you. Hardware, oh, Windows, Device Manager. And there's the Ethernet controller we passed through it. He doesn't know what to do with it because there's no XP driver, but that's the device. So again, it looks just like there's the PCI slot and all that information. Doesn't know anything else really about it except the device ID. But it doesn't know, so I would need to install the right Intel NIC driver for that guy. So again, you can do this. There's not a whole lot of reasons to do this anymore. The only time we do this, and I'll probably hit on this in the networking version of this speech, but Cisco UCS allows you to do what they call pass-through switching on Cisco UCS blade, so you can actually do a VM direct path for the NICs and still be able to do things like vMotion and DRS and HA. They do a little voodoo magic. They have you actually put a piece of software on the vSphere host on the blades called the Virtual Ethernet module. It's part of the Nexus 1000V switch, but you don't actually have to use that switch. You just use that piece of software, and it does some magic. But for everybody else, it breaks vMotion, DRS, HA, snapshots, all that stuff. So not really worth doing. But if you have a need, or more importantly, they ask you to do it on the exam, you'll know how to do it. So go to the host, go to Configuration, Hardware, Advanced Settings, Edit, Add it, hit OK, reboot the vSphere host, and then you can shut down a VM and add it as a piece of hardware. Not too crazy hard, just a lot of steps. So that's it. Back to the slide deck. So now let's talk about pluggable storage architecture, or PSA. PSA is a way that VMware created to allow for kind of modularity and extension of how storage is managed within a vSphere host. Things like how you talk to a storage array, what kind of multipathing or load balancing do you use, what happens when there's an error or a problem, and how do you manage that. So it can seem a little bit complicated at first, but I'll try to break it down and make it easier to understand and really show you what you need to know for the exam. It basically lets you insert things into the SCSI middle layer, such as EMC's PowerPath Virtual Edition. It also lets you define and configure characteristics using the default included software as well. So, what kind of storage array you have, what kind of multipathing you want to use, things like that. It's very configurable. The downside is it's not something that a lot of people work with, or if they do, you go in, you select a line, and you say, if I want to use round robin, or most recently use pathing, and that's about all you do. Some of the advanced stuff you normally don't touch too often. We do on occasion when we do implementations and configurations with multiple storage arrays, or we need to change defaults, things like that. But for a normal vSphere admin, they may do it one time and that's it. So it's kind of it's a sticky situation on the VCAP exam. So I want to make sure you understand this and understand what you need to do in given situations so you'll understand it better. VMware provides some included multipathing plugins such as NMP, Native Multipathing Plugin. There's also a second type of plugin, and this is where people get confused. It's called a storage array type plugin, and this associates with a specific array pathing. One analogy is it's like a traffic cop, so I'll come back in a second. So the second sub plugin included in NMP is a path selection plugin, or PSP. If you install something like EMC's PowerPath Virtual Edition, it basically replaces both of those. So the difference between SATP and a PSP. Path selection plugin says, I've got multiple fiber channel ports, and what do I want to do with them? So what you do is you say, okay, Do I want to do round robin, which means every time I do I/O request, I may send one or more down one path and switch to the other path, back and forth, back and forth? Do I want to use most recently used, where I stay toward one path unless it fails over? Do I do fixed, so I stay with a path, and if it fails and then it fails back, I go back to the original? It just defines how you do multipathing, how you handle path up and path down situations. SATP dictates how vSphere communicates with the storage array, and more importantly, what happens when there's a problem. So, if there is a failure or if there's an issue on the storage array and say a storage processor head goes down, what do I do? And the reason we have these storage array type plugins is because not all storage arrays are built the same. An EMC VNX is very different from an EMC VMax or a NetApp filer or a Dell EqualLogic or something like that. So you need to understand that kind of dictates those per array configuration types. There are some array specific storage array type plugins, and then there are some kind of generic ones. And then underneath those, you set your path selection policy or plugin. And so you'll say, okay, this is a certain SATP, and by default for this array type, we use this path selection plugin. So you can install, as I mentioned, third-party PSAs. This is now supported on both Enterprise and Enterprise Plus. It was originally a Plus-only feature, but they moved it down to Enterprise. I think you can thank EMC's ownership stake in VMware for that one to make it a little easier to sell some PowerPath Virtual Edition, but now you can do it with Enterprise. Again, the most common, really the only one I see, is PowerPath Virtual Edition, and the thing is it can be used with non-EMC arrays as well. And installation is pretty much the same as any other VIB. You can do it locally using VI host update, like I showed there. You can do it using ESX CLI now. You can do it using Update Manager, anything like that. So there's several ways. It's just a standard VIB install. There are 4 standard path selection plugins. Most recently used, VMW PSP MRU. Fixed, VMW PSP Fixed. Round Robin, VMW PSP RR. And then there used to be one called Fixed with Array Preference, VMW PSP Fixed AP, that's no longer available. So just be aware if you see that in documentation or something, but it's no longer an option. If you use a third-party PSP, such as PowerPath VE, these will not apply. So those only apply if you're using the native multipathing. If you install PowerPath, it's a different animal. PowerPath is not covered in the exam, so I'm not going to go any deeper into that. It's not on the blueprint, but just a heads up that if you do use a third party, you basically preclude yourself from using native multipathing. And the PSP you choose depends greatly on the array type configuration and capabilities, so we'll get to that in a second. And then I threw kind of a definition here for ALUA. ALUA stands for Asymmetric Logical Unit Access. And this is kind of an evolution of arrays, especially around what we call active-passive arrays, again, like, say, EMC VNX that I deal with a lot. It used to be with the VNX, you had 2 storage processors, and every LUN was associated with one or the other. So if you had LUN 10, it might be on storage processor A, and LUN 20 would be on B to help load balance. Problem was, you needed to dictate all access through A for 10 and B for 20. And if you tried to go through A to get to 20, it would basically have to what we call trespass the LUN and do some other stuff. Now those arrays actively can use both storage processors for access to a specific LUN. The reason I throw this out there is it will be mentioned here in a minute on PSP and the storage array type plugin, and I wouldn't be surprised to see a mention of it possibly on the exam. But just understand it's for active passive arrays. It's a newer feature set, and it allows you to access a LUN through either of the storage processors. So let's talk about the PSPs. First one is most recently used MRU. It's the simplest, selects the first available path at boot time. It's no thought, first one it sees with access to a LUN, that's the one it uses. And should that path fail, it switches to another path and does not go back to the first one should it be restored. This is the default for active passive arrays, also used on some arrays that support ALUA. So this is where things get a little bit squishy. It's getting a little harder and harder to have hard and fast rules. For example, On VNX, MRU used to be the default, and then when a software update it changed, and then it changed a couple of times. So always check your vendor documentation to see exactly what you need to use. But MRU is fairly simple. If I got 4 paths to a LUN, the first one I see I use. If that one fails, the host rotates to the second one. If the first one comes back up, it does not migrate back to the first LUN, or the first path. Is that a problem? Probably not. But some people like to dictate paths to LUNs as a primary, maybe for balancing, for storage fabric configuration, whatever. So that if the first path comes up, they do want it to roll back. They don't want it to stay with a secondary path. Most people don't care, but that is one kind of characteristic of MRU. You have fixed. It's similar to MRU, uses first path discovered at boot unless a preferred path is configured. Should the path fail, it moves to another. But unlike MRU, it will return to the original path after a failure once restored. This is the default policy for active SANs, and it's also used with some Allua arrays. I believe this is now the default option for VNXs from EMC with current code level that supports Allua. So again, it's like MRU, but when the original path is restored, it will move back to that path. Then you have round robin. It alternates between available paths to a LUN, provides basic load distribution and balancing. You can adjust how often it changes paths, basically how many IOs it sends down one before it sends down the other. It only uses the available paths to the SAN. So, I mean, this can make a difference for active-passive arrays, dictating how it defines what is an active path and available path. So it may not be as usable for active-passive as you might think. Do not use with Microsoft clustering. So that's just one of those rules due to how clustering works. You don't use round robin. And it would be a great exam topic, I think. So if you say, hey, you need to go choose a pathing PSP available, and oh, by the way, it needs to support Microsoft clustering, you don't do round robin. So just keep that in mind. And now let's talk about claim rules. So the idea of claim rules is that what if you have multiple array types? Or what if you're using something like PowerPath Virtual Edition and you need to be able to tell it which arrays you want to use that for against which arrays you want to use in native multipathing? So if you have multiple arrays or something like that, you can define them via claim rules. A claim rule basically says when you see a device, a path, a LUN, a certain device type, whatever, you can dictate, is it used by, say, native multipathing? Is it used by third party? Or is it used for something else, like we'll talk about LUN masking here in a minute. But they allow you to dictate which thing grabs it and what it's used by. So this is managed using the ESXCLI command. It's ESXCLI storage core claim. I think it's claim rules. We'll see it in the lab. And you can list the rules. You can add the rules. You can remove them. We'll look at the defaults. But the idea being you just know how to do that. The most common use for that is what we'll talk about next, which is LUN masking. And that's the most common, unless again you're using a third-party multipathing provider or multipathing protocol, such as PowerPath Virtual Edition. Really not much other use for it outside of LUN masking. And here's LUN masking. So LUN masking allows you to hide some storage components such as a LUN or an entire array or a specific path. Blocking a LUN can be useful if you suspect a fabric problem. Others are often useful in mixed environments such as labs. So you may have a lab with a bunch of different gear, a bunch of different people working, different vSphere environments, and you want to mask LUNs from a storage array, and maybe while someone else is using them so you don't see them, accidentally format them, anything like that. You manage it with the ESXCLI command. So you do ESXCLI storage core, claim rule, add the claim rule. You do -R for a rule ID, which is a number. -T is type, and we'll talk about type. That's going to dictate vendor, LUN, array model, whatever. And then -P is the mask path. So the storage plugin that you're going to use is a hard-to-find one called mask path, and it masks the path to that device. So this leads into tagging SSDs. So SSDs can be useful to enhance performance. We can put swap file space on them. We can make them fast data stores. We can do different things with SSDs, but the vSphere host needs to know that they are SSDs. So you can do this one of a couple ways. It's best to confirm that vSphere is detecting them correctly, and it will actually show that if you look at the properties of a LUN or a disk device, it'll show us an SSD. But what if it doesn't detect them correctly? So then what you can do is say ESXCLI storage, NMP, then we set a storage array type plugin, SATP rule, add. So you'll say SATP VMware SATP local, which is for local disks. So let's assume this is a local SSD in the server. Dash device, and that's just the path to the device. You can see that within the VI client. Dash option equals enable SSD. So let's say you put SSDs in your servers. You want to use it for local fast vSphere swap space. You can do that. That's a feature that's available now. But it has to detect them as being an SSD to properly use them. So if for some reason it's not, it uses a standard SCSI command to query to see if they're SSD, but if for some reason it comes back incorrectly, you can do this storage NMP SATP rule to tell it to add them. And then the next line is the SXCLI storage core claiming reclaim -D. So it basically says, okay, as soon as that disk was detected, one of the storage array type plugins already claimed it. So now we're going to tell you to reclaim it. So anytime you change a claim rule, you need to do a reclaim. And that says reclaim the device and gives you the device ID. So let's put it all together. NMP, native multipathing, calls the path selection policy assigned to the storage device. The path selection policy selects an appropriate physical path on which to issue the I/O. Remember, this is most recently used, round robin, fixed. It figures out which path to use. If the I/O operation is successful, the native multipathing reports its completion, yes or no. If it reports an error, the native multipathing then calls an appropriate storage array type plugin. Remember I said if an error comes up, the normal path selection policy doesn't know how to handle that. He just knows how to feed IOs down a given path. He doesn't know what to do when something goes wrong. So when something goes wrong, he turns around, looks at the SATP and says, now what do I do? So SATP interprets the command error and when appropriate activates an active path. So again, it's supposed to understand the type of array and kind of understand the feedback that it's given. You know, it may just be a dead path. The array may say, look, this LUN now lives on another storage processor. You need to go to SPB and pick a different path. Whatever, the SATP interprets that. And then the PSP is called to select a new path on which to issue the I/O, and I/O should resume. So that kind of puts things together for you. So path selection policy dictates which path to use. Storage array type plugin dictates how it talks to the array and what happens when an error occurs. So now let's jump to the lab. In the lab, we are going to view the current PSA config, view the current multipathing config, manage PSA and multipathing configuration rules, and configure a claim rule. So let's go ahead, let's jump into the lab. So the first thing I want to show you is what you can do from the UI. So most of these things are set, well, claim rules are set via the command line interface. Storage array types or plugins are really configured through the command line interface. But we can set the PSP, the pathing policy, from within the GUI. So here's one of the Vero labs. This is a UCS cluster, and I'm using this one right now because I have access to Fiber Channel. So we'll pick a host, we'll pick configuration, we'll go to storage, and I'll pick one of our Fiber Channel data stores. And we can see some information down here. You can see VAI acceleration is supported. We can see that path selection policy is set. That's actually a third party. Is there any of them that are not including? No, well, that's fine. It won't hurt anything. But we can do properties and take a look at the configuration. So a couple of things here. Nothing really here except for the device ID. Let's click Manage Paths. And then we can see a few things. So our storage array type plugin, our SATP, is VMW SATP Alua CX. This is an EMC VNX array. It supports Alua, and that is the storage array type plugin for that device. And up here we can change and pick what we want to use for our PSP for each individual LUN. Now, ignore the PRNX options. This is actually Pernix data. We are doing some testing with their software. They do server-side SSD caching, and one way they do it is by replacing the multipathing that comes with VMware. So just pretend, especially for the VCAP, that you didn't see those. The ones you would see would be MRU, round robin, and fixed. So you can go in here and change it. We can do it from the command line, but I'm probably going to do it right here from the UI since it's a lot quicker. So you just pick and choose, hit close, and it'll change the pathing for that. So if it's got 3 paths, you could say, you know, round robin, it'll go through all 3. Most recently used or fixed, it'll use the first one it finds until there's a failure, and then it'll use one of the others. But you can check your SATP and your path selection policy right here within the UI. Let's see, let me make sure I didn't change that. Nope, we're good. So let's close that. And jump on over to the local lab. So let me SSH into a host. Yes, please. So as I said, most of these are done, or actually all of them I guess are done via the ESX CLI commands. So it's ESX CLI storage. And let's do claim roles first, which is core. You can do claiming, which is going to show you basically, you know, you can instruct it what to do. You can auto claim, claiming mode allowing the disabling the automatic claiming process. You can reclaim, attempt to unclaim all paths to a device and then run the loaded claim modules on each one. We actually saw that, if you remember, for the SSD claiming. So we actually defined which SATP would take it, would grab it with an option for SSD, and then we would run the reclaim command here to say, okay, now step back through the claiming rules and make sure you don't need to reclaim any of those devices. So that's what we did there. You can use the unclaim command to unclaim this, you know, just if you want to stop the claim rule. Let's see, claim rules. So we can do list, and this shows the default claim rules. So let's see. These are all, you can see these are the defaults. USB, SATA, IDE, block, and unknown are by default grabbed by the native multipathing. There are 2 here that were added for Dell. These are just defaults. Dell, for these universal export, these are special LUNs. I think they're like control LUNs that show up from this Dell equipment, and by default they're masked from the vSphere host. So all of these are the default rule set. If you want to add one, it's pretty simple. I'll show you some of the commands here. So you can add a rule. You can convert an old ESX3X rule. I wouldn't worry about that for the exam. List the rules like we just did. Load them from a config file. You can move one from one rule ID to another. You can remove a rule and run the claiming rules to execute against your devices to see what you need to do. So let's see. Claim rules are on the blueprint. So my guess is, at least know how to write a claim rule. So you do a claim rule add. And the nice thing is you'll see a lot of these commands give you a bunch of examples. So if you get in the exam and you run your claim rule and you're like, man, I know how to do this. Jason taught me how to create a claim rule. And then you're like, oh man, I don't remember what my options were. Of course it lists them up at the top. You can scroll up and see those, but it also lists them here. So a common one, I would probably say ESX CLI storage core claim rule add. Let's see, you got to give it a rule ID. Just pick a number. I'll do 305. And then let's say we want to add an array type. Let's say, like I said in the slides, the most common use case for this is for masking LUNs or devices. So let's say we got a new experimental array from Nash Corp. That's what I call my lab. And we want to mask everything from it. So we'll do add-r305. And then we would say, so you can do it by driver type, you can do it by vendor type, you can do it by model type. Let's see, dash type vendor, dash vendor is Nash Corp, dash model is Fast Array 5000. And then we want to pick the pathing, which would be, let's see, I believe it's, what is it, LUN mask? It's on here, I always forget that. Oh, mask path, that's it. So, dash T tells you the type. Let's go up here. This is the type. So, indicate which type of matching is used for the rule. So, you can do vendor, location, driver, transport, device, target. You pick one of those. So, a device, you'd have to give the device ID. For transport, it'd be whatever the transport is, kind of like we saw. If I scroll up, yeah, these are transport types. So, transport USB, SATA, IDE, block, or unknown. Again, the most common, I think, is going to be like a vendor. So when it detects this array, you're going to have to know what the vendor and model it's going to detect as. and you can pull that. It's actually shown within, like, let me jump back to this lab. So we can see that, I believe, here. Is that correct? I think that's right. You can do a properties on that array, VNX. It shows the inks. Oh, and there's the device. So it'll show like the device, DGC fiber channel disk. That is for EMC. They still use the old Data General Corporation naming. So you can see that. You can see the device IDs here, you know, the NAA numbers. So there's several ways to get this information. But again, I'm just going to use a vendor, and then M is your model. So right here, model, indicate the model of the paths to use in this operation. So you can just do that. And then P is your plugin. Which PSA plugin do you want to use? And again, if we want to do LUN masking, we would just say mask path. So ESX CLI storage core claim rule list. And we're going to see my new 305 claim rule right there. So again, that's an easy way to do it. If you wanted to do a specific LUN, you could do the device and go grab that device ID like I just showed you. You could do target, like they've got an example here. So you could say, you know, use native multipathing for this specific target fiber channel, and we talked about WWNNs and WWPNs when we talked about fiber channel and NPIV. So you see those there, and those would be for the target array. You could do it for iSCSI here. Instead of using WWNNs, PNs, that uses the IQN for iSCSI naming. You can use that there. You can do here a location, I guess, if you wanted to. This one is using your HBA, so it's a virtual HBA and your target or your device. Here's another one that's using a VAAI filter. You could actually say disable VAAI for this device and give it that, and then the device would be your MPX VMHBA. That's actually a fairly good use case right here. That's one I forgot. So you can filter out VAAI by specifying a device, an array model, whatever, and that's another one. So if you just wanted to say, hey, I want to use VAI, enable it on my host, except I don't want to use it over there. Within the vSphere GUI, you can't say yes here but no there, but you can do this using your claim rules. So that's a good one there. But again, usually we see this for masking a path to something. So next, let's take a look as XCLI storage at the native multipathing. So a couple of things here. Native multipathing, there's not a whole lot to do. You can list your PSPs like we just did. You can say, you know, VMware PSP MRU, round robin or fixed. It just shows the available ones, and you can actually do some things like, let's see, you can, it says operations pertaining, so you can do fixed and device config, and then you can say set. I'm just walking through this. But then you can say things like, you can come through here and command line set for this device, specifically which path you want to be preferred. A lot of these things you can do, I believe, quicker through the UI, but you can walk through here and set those right now in the GUI. You know, not bad. Let's see, device config. You can also do a get, so it'll show you some information. You can specify the device, which is required. I don't really have a device that's using it, but you could pull up the device if you have the device address. The one I really want to show you is NMP SATP list. So this lists all your storage array type plugins here on the left, and then it lists the default PSP in the middle, I guess, and then it shows a description on the right. So this is all the currently installed or available storage array type plugins. So you see them for different things. Here's one for HP EVA, Dell EqualLogic, MSA from HP, CX for EMC arrays, Symmetrics is an EMC array. You've got the Alua version for the one for the EMC array. So they're in here. What you probably will need to know, and honestly, about the only thing we do here in the real world, is change the default PSP for one of these. So the reason we do it in the real world is, for example, EMC eventually went through to changing the Alua default here. So it was fixed. Let's see, I'm trying to remember the order, but it changed from fixed or MRU to round robin, and it changed with software updates. Well, you can either go through and update every LUN that you add, or you can just come in here and change the default. So let me show you how to do that. So list, it's a set command, and it's right here. So you do, let's see, this is your SATP type, -S is, and I wish they'd pick uppercase or lowercase, but I'll change local. So this is for all local disk, which normally is fixed, because usually there's only one fixed path, but it makes a great example. SATP local, and then just a -P, what you want your new PSP to be. So VMware PSP, right now it's fixed. Let's change it to round robin. It says default has been changed, list, and you'll see it changed. So that's probably the one thing you're probably going to need to know for the exam. And again, it's the one thing that we normally use in the real world. So don't let the pluggable storage system architecture, PSA, overwhelm you. It can seem like a lot of different things. I mean, really, it's claim rules for claiming devices, for doing LUN masking, stuff like that. I would know, I showed you the commands for doing, say, an SSD. I would at least know the function of that. That's documented in the, I believe it's a storage guide as well. I'd know how to do that. I'd know how to mask a path. I would know how to change the default like I just showed you and pull the information. I would probably, if you're asked to change it on a specific device, go change LUN 18 from fixed to most recently used. I'd do that in the GUI, only because you're going to have to look up the device, you're going to have to come to the CLI, you're going to type the commands in, and you're going to have to make sure you get it right, or you could just do about 6 clicks in the GUI. And again, this exam is not about how you do something, it's about the end result. You figure out the fastest way for you to do it. So that's it for the lab. Let's jump back to the deck. Now a little bit about iSCSI, mainly iSCSI port binding. So I'm gonna use my usual excuse here, but the basic iSCSI configuration is considered VCP level information. I'll walk you through it here in a minute in the lab, but know how to do that, know how to do basic iSCSI configuration, know how to enable it, know how to get your IQN, know what you need to do there, know how you need to map your LUNs. Really, it's easy because you're not going to have access to a storage target. At least I don't expect you to have access to a target. It's not listed in the blueprint of the description. So you'll only be doing stuff from the vSphere side. But one thing that is, again, hidden in the blueprint, and definitely is fair game, is iSCSI port binding. So one cool thing about iSCSI over, say, NFS, I'm a big fan of NFS, but this is one thing it can't do, is multipathing, MPIO. You can bind multiple 1 gig or 10 gig or whatever NICs you have together to get more throughput for iSCSI. With NFS, you can't really do that. So it's a nice feature. And basically, it's pretty simple to do this. It used to be a lot of command line stuff, but with current versions of vSphere, definitely 5, you can do it through the GUI. And you can create multiple VM kernel interfaces, and then you attach them to specific NICs. Now, you can create these VM kernels on CLI or the GUI. I don't care. VMware doesn't care. Normally, I'm a CLI person, but I keep finding myself in this course telling you to do things through the UI only because I think it's quicker. But if you're really good on the CLI for creating VM kernels, knock yourself out. Nothing special here. So I'm going to show you how to do this. It's easier to show you and better than it is to tell you. But basically, we're going to create 2 VM kernel interfaces, and we're going to bind them to physical NICs, and we're just going to show you where to confirm everything and that you're good to go. So with that, we'll go ahead and jump to the lab. All right, so here we are back in the lab. And for this little fun, we'll use host Megatron here. So first, we go to configuration, to storage adapters, and we need to add iSCSI. So we'll do add software iSCSI and hit OK. So give that a second, and it will add the iSCSI software initiator. So next thing we need to do is configure some networking. While it's doing that, we'll go do this. Now, you don't have to do this unless you want to do multipathing. It'll actually use your a regular VM kernel interface, but it's going to be shared, and, well, I guess it doesn't have to be shared. If you create a VM kernel on the iSCSI network and just use it, it'll work kind of like what we used to do in the past. But if you want to do multipathing, there's a couple of things you need to do. So let's go to networking. And what you need to do, there's 2 ways to do this, and I'll show it to you. So let me add, and we're going to do a VM kernel interface. We're going to create a new switch. I'll do it with both NICs. 2 and 3 are free and available. That's why I'm choosing them. And then if I want to give it a VM kernel interface, we'll say, VM kernel iSCSI1. VLAN in my lab is 5. And type is IP. Next. And give it an IP address. So I'm actually just going to tell it to DHCP. I know you should never do this, but I didn't pull 2 IPs, but I'll just grab them since this is temporary and say next. So it's going to go ahead and create this, and it's going to create it with 2 NICs. So then I want to come back in here and I want to add another one. Another VM kernel interface. Call it VM kernel iSCSI2 5 management. Actually, no, I didn't do that. Not management. IP and automatically. I know. All right. So now here's the gotcha. The gotcha is that you can't let both of these guys use the same NICs. So you override switch failover, and for iSCSI1, I'm going to tell him to use NIC 2, and the other one is actually unused. And for iSCSI2, I'm going to do the opposite of that. So I'm going to leave 3 and move him to unused. We'll say OK. The idea being is you're basically mapping VM kernel interfaces one-to-one to physical NICs. So let's go see if this worked. Back to storage adapters. iSCSI is now installed. Let's do a properties. Here's your IQN I said you'll need to know how to get. Hopefully you know how, but here it is. If you have to enable CHAP authentication, you do that here. So if they give you a login information, that's where you would configure that. Advanced is some simple advanced configuration options. I don't think you'll see those. Configure is just, if you want to change your IQN or anything like that, or you just want to temporarily disable iSCSI, you do that there. Now let's go to network configuration. So right now the VM kernel port bindings are blank. So let's click add. And it shows us our 2 VM kernels. So real quick, if you come in here and you click add and it's all blank and doesn't show you anything, it thinks that you've configured something wrong. Normally that means you have 1 VM kernel interface with, say, 2 NICs as active or something like that. So it's not going to show that. It's got to be a one-to-one mapping. So it says, hey, you can use these. VMK1, VMK2, gives you some information. Yay, we'll say OK. Add VMK2. OK. And now it's going to use both of those. And next you just go do your discovery like you normally would. In my lab, that is my iSCSI target. And we'll say close. And it's going to say, do we want me to rescan? And I'm going to say absolutely. And then it's going to come up and say, I see 4 targets, 3 devices, a total of 12 paths, and that is correct. So it's using all my paths and doing everything as it should. So let's do properties again, network configuration, and we'll see my active paths there. So it's nice and happy. And port group policies compliant, so it's doing the correct thing with the one-to-one mappings. And really that's it. It used to have to do this via the CLI, create VM kernels, map them over to the right iSCSI target, and it was just kind of a pain. Now it's easy. The other way to do this, just so you know, is to actually create 2 vSwitches. The first vSwitch, like vSwitch 1, with 1 VM kernel interface and 1 NIC, and then a second vSwitch with the second VM kernel interface and the second NIC. In the end, you're doing the same thing. It just depends how you want to manage it. I personally prefer the latter. I prefer the 2 separate vSwitches because I can walk in here. I can go into the configuration to networking, and it's laid out there for me. This is a little bit, I have to go in and go, well, did they do this right? I have to go look at my network adapters. I have to scroll down, have to go active, VMNIC 3, unused. Okay, yeah, they did that right. So to me, it's easier to look at, but it doesn't matter as long as you set it so it's a one-to-one mapping. And again, once you've done that, go to storage adapters, go to properties, go to network configuration, assign these, and make sure everything is green and happy. But that's it. The only other things I can think of for the exam for iSCSI, I just showed you how to install it, which you should probably already know. CHAP authentication is easy. I showed you that. If you get that, you just punch in your logins there. And really, that's all there is to it. So with that, let's go ahead and jump back to the slides. Now a little bit about storage queues. Commands to storage are queued in two places. And what I mean by queued is you got a VM, got a bunch of VMs. They're throwing read and write requests to your storage array like crazy. Odds are your storage array, if they're getting a lot of requests at one time, can't process them as fast as they're getting them. That's a pretty common problem. So what happens is those commands start to form lines or queues in a couple of places. One is at the host, kernel, and the driver. Here we have a default queue depth of 32, which can be adjusted, meaning there can be 32 I/O requests at the host waiting to go to the storage array. And then you have a queue at the array, and that depends on the model, make, manufacturer, specifications of the array. Some arrays will have, a queue depth of 2048. Some will have less. Some will have more. But in the end, you got to worry about what happens when these queues fill up. So normally things queue at the array, then when that fills up, they start queuing at the host, unless your bottleneck is like your HBA, and then they'll start queuing up at the host. So as things backlog, requests start waiting to be serviced. So as a queue increases, so does the latency. And that's a given. I mean, if I'm sending a read IOP or IO request and it has to sit in a queue for 10 milliseconds, that's 10 milliseconds, nothing's happening. Even if the storage array gives it back to me in another 10, that's still a total of 20. So it does add it to latency. You can adjust these. Most fiber channel HBAs, which are the kind of the host queues, can go up to 255. Highly suggested that you don't max that out. Usually recommended no more than 64. If the HBA queue depth fills up, commands start overflowing to the kernel queue. You don't want that to happen, so then you're going to say, well, Jason, why don't I just set it to 255? Because it's indicative of a larger problem. If you're starting to back up queues more than, say, 64 on an HBA, you need to figure out what's wrong. Odds are your storage array is undersized, doesn't have enough spindles to meet your I/O requirements. You need to fix that, not have the I/Os queued up at the kernel. That's a bad thing. So you can change queue depth. Here's the thing. I don't think they're going to ask you this on the exam. The way to do it is a KB article because it varies by vendor. Emulex is different than QLogic, for example. So I'm going to give you the KB article 1267. It's like a really early KB article, one of the first. But I don't expect you to have to know this. But queue depths were mentioned in the blueprint, so I don't know what they're going to ask you about. We'll hit on this when we talk about storage performance monitoring later in the course. When we look at, say, ESX top, you can look at, the queues. You can look at device average latency, kernel latencies, things like that, and it's kind of a good understanding of how this works. But I don't expect them to say, go change this in the exam. You can't change a storage array. That's out of scope of the exam. And really, I don't think they're going to tell you to go change it for an Emulex. And, it doesn't say anywhere in the exam description that you have access to the KB, just the documentation set, and that's not in there. So that's the long-winded version of me saying, good to know how, not sure they're going to test you on it. Oh, Duncan has a good post on this. So Duncan Epping, if you don't know Duncan, you should know Duncan. He works for VMware. He and a guy by the name of Frank Dinneman have written a couple of really great books on HA and clustering, and they do a lot with other kind of advanced aspects of vSphere. He has a great queue scheduling overview on his blog that I suggest you do read. It's not a long one, and I think it's well worth reading before you go take the exam, just as a kind of a bit more information on queuing in case you get hit up on something. And that's it for this lesson. So this is kind of, I don't know, it feels like a long lesson. There's a lot of stuff here. A lot of different pieces and parts. Really one of the first lessons where I think we get into the technical nitty-gritty of what you could expect to see on this exam. I have taken, obviously, this exam. It is, all lab, and it's 100% technical, and it's 100% go do this, go figure out how to do that, and make it happen. So again, know your ESX CLI storage commands, know what claim rules are, know how to add one, know how to change the default PSP for a storage array type, know how to set up your iSCSI VM kernel interfaces, make sure you map those guys one-to-one, at least have an understanding of queue depths. I don't think you need to go crazy deep on that, but have a good understanding. But we're going to continue to build upon this as we go through, especially probably a bit more when we get to the performance tuning lesson. So with that, I look forward to seeing you on the next lesson.